Okay, so this is the 2010 surface geometry question. It's the cooker hood question. So I have set up quite a lot of it. I've drawn the front elevation and I've drawn as much of the plan that I possibly can. So what we have to do is complete the plan. So what we have of the plan is this much, in case it's not showing up right in the camera. We have come down this far, and this is hidden detail down in here. Going right around the rectangle. Now the scale was 1 is to 5, so that means every measurement that you see in the question in your book, just divide by 5 as you're setting it up. And the front elevation looks something like this. You're told in the problem that the surface A and C have a pitch of 45 degrees. That means the angle between here and here is 45 degrees when you're setting it up. Okay? In case you're wondering. So it's 45 degrees on both sides. You're told that. The only reason why I can treat that directly as a 45 degree line, like I don't have to do something like what you do in your mock paper where you have to look along a line, is I am looking along a true length already. That is a true length of 350 mil to scale, which is, when you divide it by 5, 70. So that's a true length of 70. When I look along it, it becomes a point, which means I can measure the 45 degree line out when it comes to setting up the front elevation. Okay. To get the arc on top, I bisected this line in half and I found it. So, to complete this hood, we need to draw an end elevation. Now, you could draw the end elevation here or above on the XY. It makes no difference to solving the problem. I'm going to draw it on top of the XY as it was an orthographic question. So, I come out at 45 degrees from the widest corner. 45 is half of 90, that's why I'm using it. And because I'm trying to turn through 90 degrees. Bring across all my points. Bring them straight up. Draw what I can of my front elevation. Okay, so on the end view, we have this much, heavy. Like this is irrelevant really. If you made a mistake here drawing the end view, you know, if you didn't get it exactly absolutely 100% perfect, like for example, a very common mistake where someone might draw that fully back in there and forget that it's actually back in a few minutes. You're not going to lose a whole lot of marks here. You know, don't have to be too worried about it. The most important about the end view is that it helps you complete the plan. And by having the plan completed, it helps you solve the rest of the question. Okay, so we can draw no more because I need to know where these lines are here in plan. You are told that surface A, which is located here, that surface has an angle of 40 degrees. So that means using a protractor in your end view, you can measure off an angle of 40 degrees. That's what surface A looks like as a line in the end view. You were told that in the question, that has a pitch of 40 degrees. Now you can complete your end view, which means you can complete your plan. Okay, so you just bring these points back down, so you're going backwards now. You bring these points down, so, and across, which allows you to complete the location of the hood. Now, I know that your lad's in 6th year, but really this is very junior cert yarn level, what I'm doing here. Okay, just, it would have been another solution. You could have drawn this down here. You did not have to draw it up here, side front elevation. You could have drawn it down here. You would get the exact same solution. So you could look perpendicular to this line, draw a new XY line. The heights that are here are the same as the heights from here. Draw your elevation here to complete this view. Would have been identical. Just this would have been down here to one side. Something similar to your mock exam. Now, you're asked then in the question to find the dihedral angle. You're asked to find the dihedral angle between surfaces B and C. Okay? So we're asked to find the dihedral angle between surfaces B and C. Let me just double check that again. Yeah, B and C. I have something labeled incorrectly here by accident. That's not A, that's actually B, C, A. And so that means this is B here. So we have to draw, find the dihedral angle. So find the dihedral angle, you need 3 easy steps. Number 1, find the line of intersection between the two skew lines. Between the two surfaces. Number 2, find the true length of this line along with 2 extra points. Number 3, look along this true length and find your dihedral angle. So between B and C, the line of intersection is this line here. That is our line of intersection. So I'm going to look perpendicular to that. I bring out one end of it. I bring out another end. I'm going to just change using longer set squares because I have to go outside my drawing. And then we bring 1 point from one surface and another point from another surface. So I've already brought out 1, 2 in front elevation. That's 1. There is 2. I'm also going to bring out 3 from surface B and 4 from surface C. There is 3 on surface B and there is 4, same place as 2 on surface C. So I'm going to bring out them points as well. So I bring out 4. And I also bring out 3. Wherever I want, I draw my new XY line perpendicular to that line. Plan XY elevation, therefore the height of this elevation will work in this auxiliary elevation out here. Okay, so this is the height of 1. Take that height, I map it off for 1. This is the height of 3. Bring that over here, map that off for 3. Height of 4 is the same. There is 4. Height of 2 is the same. There is 2. 1 is joined to 2 because that's the line of intersection. I join 1 to 2 here, and now that has found the true length of line of intersection. I then look along the true length of the line of intersection and I bring points 3 and 4 with me at the same time. So I bring one down along the line 2, 3. I bring down 4 at the same angle. I bring down 3 at the same angle. And where I want, I construct my next XY line. Now, to get the answer here, I need to work from this XY into this plan. We'll work from this XY into this plan. However, this XY is a very, very long way away. It's miles away. So I'm going to actually take that XY line and I'm going to shift it down really, really close. You can do that in the exams so that you don't go off the page. And because I'm on camera here, I don't want this to go off the page while I'm on camera. So I'm going to take that distance, it's there, that XY, and I'm going to slide it down nice and close to 4, 2, 3, and 1. So it's called a temporary XY, and it'll still get the exact same answer. Okay, now you wouldn't have seen me do this in class much. You don't have to do this. You can take the distance from this XY into here, let them go off your sheet, that's fine. I just don't want that happening in the video. So from this XY to 4, we'll work from this XY to 4. From this XY to 3, we'll work from this XY to 3, which is actually still going off my sheet, so I'm going to have to move that temporary XY line closer. It's quite a large dihedral angle in this question. Okay. So 4 has a 0 height, so that means 4 is on the XY line. I'm not using that one now because I've set up again. I go from this XY to 3, is this XY here to 3, just here at the bottom of my sheet. There is 3, and now I need to get 1 and 2 through the same distance. This XY to 1, which is the same as this XY to 2. 1 and 2 are on the one line. There is 1, 2. You know you're going right if, when you get 1 and you get the hedron angle, that your true length of your line intersection appears as a point. So now that is your dihedral angle found. Get your protractor, measure that angle. So for me here today, it's measuring up to be 119 degrees. Okay, so that's part A and B done. Now, you're also asked to do a development in this question. You're asked to develop surface B and C, and I think you're asked to develop the hood on top, which is surface D. Yes, so you're asked to do the development of D, which is here, and you're also asked to develop B and C. Now, I want you to try that yourselves. Okay, the development is not that difficult. There's a lot of tricks in that you can use to try and solve the problem. As a hint, what I would tell you to do is, I would find, well, you actually have very little you need to find. You have the true length of 2, 3. You have the true length of 2, 4. They're there because you're looking down top of them. You have the true length of 1, 2 out here. You have the true length of 3 going up to this point here, which I will call 6. So you have 3, 6. And you have the true length of 4 going up to here also. It's there. So we'll call that 4, 7. 7 and 1 share the same place. So you have the true length of all of the sides of the object. What you need to do then is to set it up and to draw it out. So I'll do it very quickly over here on the white side of the page. Okay, it's not difficult. People would read that question and think that will be quite difficult. All you're doing is you're finding the true shape of these two surfaces, like what came up in your mock exam. So over here to one side, I'll set up a random construction line wherever I feel like. Doesn't matter where I put it. I don't want to keep in white space, so I'm drawing. Draw a random horizontal line. I'm going to put 2, 3 onto that. There is 2, 3. Okay. Now, next thing. I need to find where 6, 1 would be. Now 6, 1 in this plan should be that far away, but they're not that far away because that's tilting at an angle. It's tilting at 40 degrees. So therefore, the distance apart is actually this 40 degree line over here, which you can mark off over here. So that's the width of surface B now. That's the width of surface B now. If I then get the true length of 1, 2 on my compass, which is over here to one side, put it here at 2, swing an arc, where that cross over that line, that must be 1. Put over here at 3, swing an arc, where that cross that line, that must be 6. So that is the true shape of surface B found. True shape of B. Next thing we need to do is add on the true shape of C. So I've already got one line for C. It's this line here, 6, 3, or apologies, it's this line here, 1, 2. I've already got one true shape, 1, 2, 1, 2. What I need to find next then is 7, 4, and 2. Same technique as last time. The distance from 1, so across this surface in plan, appears to be this long here. That's not true. The true length of that line is actually from here out. That's the true length of it. So if I apply that length out here anywhere, and again, take that angle that's there, slide it up, draw it across. My objective now is to find from true length from, okay, 1, 2, which we have. I need to find from 2 to 4. 2 to 4 is out here somewhere, so I get length 2 to 4. Sorry, as I put that distance in the wrong place, it's actually not there yet. I wasn't thinking. We'll use that in a few minutes, or just have to ignore that for a second. So out there now, 4 is out there somewhere. It is perpendicular to this line away from it. Remember, I'm just folding this out flat. So that's where 4 is. Now I apply the logic that I used a few minutes ago where I made a mistake. I take this length here, swing that out from there. I don't even need it because it's just going to be from 1 straight out like this. So all I have to do then is get the true length from, I have 4 to 7, which is here, true length from 4 to 7. Swing that off. And here is my answer. So there, 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 there. C. Okay. If the development is giving you any trouble, I'm going to do it in a separate video, which is further down along. I'm going to show a different technique for getting the development. So if you can do this much of the problem, the development will be on the next video. Thank you.